Hello, my name is Shamus French. I'm going to present iterative design patterns for you today. So the intent of an iterative design pattern in software engineering is to give you a means or an option to be able to access and traverse elements of a collection of objects in a sequential manner. For example, start at the first one, go to the next one, the next one, the next item, and do things on each one depending on what type of item it is, what type of object. It makes it so you can traverse different types of data structures in a uniform method. So, for example, if the collection has different types of things, uh, I'm going to use an example later, program example, where we have our different types are an animal of type wild or an animal of type domestic, and traversing it, doing certain things if it's looking for only the domestics or looking for only the wild animals. So the structure of a iterative design pattern is kind of like this. And what happens here, we have a client. We also have our iterator template, and we use the iterator template to create instances of concrete iterators. And in these concrete iterators, we can override, and define different ways of traversing or different methods, functions to be, operations to be done while going through the collection of objects. We also have our aggregate and our concrete aggregate classes. So the participants, as you just saw before, are the iterator. It kind of defines the interface for accessing and traversing the objects. Uh, it defines the interface, but we can override it and create concrete iterators. We create concrete iterators, and we can do different types of operations. The concrete iterator has the job of keeping track of the current position and traversal of the collection, and it kind of implements the interface for the certain type of iterator. So what are we going to do, for example, for the wild iterator? How are we going to traverse it, and what are we going to do when we actually find a wild operation iterator? The aggregate class defines the interface for creating the iterator object, and the concrete aggregate implements the iterator creation interface to return that instance of the proper concrete iterator. So when we create an iterator of a certain type, it returns that iterator with those overridden functions, methods. The consequences of the iterative design pattern are, well, it makes it possible to traverse it in different ways, like I said. So you can go through and you can, for example, you have wild animals and you have domestic animals in a list, and you're going through this list, and when you find a wild animal, maybe you want to domesticate it, make it domestic, you can do that. Or maybe you want to have a different iterator that when it goes through the list and it finds a wild animal, it prints out, hey, found a wild animal. But if the next one is a domestic animal, it doesn't do anything, it just goes to the next one until the end of the collection. Or maybe you want one that only goes and finds the first three. You can define these in all different types of ways. And it makes it a lot simpler to do it this way, because if you want to go, you can define many different types of ways, many different iterators using the iterator template. And as you go through, if you want to change that code, it's very easy to change that code because the interfaces are kind of abstracted. The operations and responsibilities are taken away from the collection of objects and put into the iterators. So this also allows for you to do more than one traversal at the same time. So if you have a big data set, you can go ahead and go through the data and do it. You can maybe have threads and have different traversals happening. And if the possibility arises for you to have threads that are relying upon each other. For example, you have two iterators that go through, and if it finds this one, it triggers the other iterator until the other iterator uh, finds the end of a certain type of objects in the list and then triggers a different one. So some of the known things that use the iterative design pattern is the C++ language. The Iterative library has a lot of stuff in there, including arrays that use pointers, so array of pointers. In Ellenbogen's class, we use this, and we have Java uses it. The list iterator, that's kind of what we use in our thing, in the example that I'm going to show you in the next slide. And then .NET also uses the iterative design patterns. So it's used basically in most commonly in object-oriented systems. So the demo application that I'm going to use here, I did not create it, but what it is it's basically a zoo. And in the zoo, we'll have wild animals and domestic animals. And these animals have names connected to them for the data structures names connected to them. And so they're in a list. And we're going to define concrete iterators to go through a certain way and do a certain types of operations. So in this one, we're going to define the first one to go through and print out only the wild animals in the names. And then after it goes through that traversal, we're going to create another concrete application or concrete iterator, go through and find only the domestic animals and print those out. So as you can see in here, I'm going to go through it. In our main, our client, we're going to create the zoo, the object is zoo, and here's the zoo implementation right here. Create the list, and then it gives you the functions for the getting animals, adding animals, removing animals, and then also create iterator to return wild, return domestic. And after this, we start adding, we had 5 animals, wild, wild, domestic, with those names, calling the animal. The animal class, just so you can see it, is right here. The animal class has the animal name and the animal type, and they are both put in there. As you can see, the animal name and the animal type. And then we have our functions here: get animal, set animal, get animal, set animal type. And going back to the main client, the main, once we define all our list, these are in the list, array list right now, and they're 0, 1, 2, 3, and 4. So there's 5 elements. Next, we're going to create an iterator and define what we want it to do. And what we're going to do is we're going to do create a wild iterator. So right here is our wild iterator implementation. So it goes through and it only prints out, if it gets the animal type, and if the animal type is wild, it prints out the wild animal and the name. And so this will go through all the elements and do that. And then after that, we're going to go through and we want to find which ones are domestic. So this is an iterator again, but defined in a different way. So this one's going to be right here, the domestic iterator. It's going to go through and instead of wild, it's going to look for domestic. And if it's domestic, it's going to print it out. Now these iterators have the responsibility, as you can see, of keeping track of the position and going through. And so this contains all the operations and the responsibility of how to traverse the array list. So once we get done with those, that's the end of the application here. And right here down here is the output of me running the application. So it actually, since there's 5 elements in the list, it's going to run twice, so it's actually going to look at 10 different elements. But as you can see here, the elements are in the order wild, wild, domestic, wild, domestic. They're not they're not all grouped together. They're kind of random. But down here you can see the first time it goes through, it prints out only wild animals. There's only three of them. And the second time it goes through, it only prints out the domestic animals. And there's only two of them. So, using Oracle or using Eclipse, I created a class diagram for this. And in our class diagram, you can see we have our client or iterative sample that contains our main method. And then we have our iterator interface, which is right here. And we also have our concrete iterators, wild and domestic. So these are the two different types of ways that we're going to iterate through what we're going to do when we're iterating through. These contain the responsibilities of keeping track of position and everything. And then we have our aggregate, which is right here. And we have our interface, and then we have our concrete aggregate, which is right here. And this is uh, kind of how we define the animal. This is the data structure type of animal. So yes, in this case, they're all the same uh, type of data structure, but what we did was we went through and we did something depending on if it was wild, of type wild, or type uh, domestic. Now, we could also define more different types of data, so animal, car, and stuff, and we could go through it and we could uh, do it that way, or we could do int, string, list of combine different types of things. All right, this was iterative design patterns, and my name is Seamus French. And I hope this clears it up a little bit for you.